So the title of the lesson today is The Law of Sines, the Ambiguous Case. And up to this point, all we've dealt with our law of sines problems are given two angles and a side. But we know that law of sines can be used for a side-side angle as well. And given that side-side angle case, there can actually be multiple types of solutions, 0 solutions, 1 solution, or actually 2 solutions for a given triangle. And we're going to take and go through each of those with this side-side angle given. So here we have a triangle where angle A is 145 degrees. We have side B of 10 and side A of 2. So here is angle A. Here is side A. Here's, let's call this B right here, 10 here, and C right here, and little c here. And we want to solve that triangle. Now right off the bat, I'm looking at this and going, hey, there's something up here. And if I look at this, I say, well, 145 has got to be my biggest angle. Now from geometry, we know that the biggest side has to be opposite the biggest angle. So once again, in this case, we have a side, and an angle given, which is the premise of the day. But I don't have the biggest side opposite the biggest angle. This is an invalid situation that they've given us. So we say there's no solution. Let's say you don't recognize this right off the bat. You can still set up law of sines and say that the sine of 145 over 2 equals the sine of B over 10. Therefore 10 sine 145 over 2 equals the sine of B. Sine of B would be equal to 2.86. And then when I take the inverse to find B, I get a no solution case. So it would come out in your calculations even though you don't recognize it. So here's a situation where I have a side followed by a side followed by an angle, and there were no solutions. So we took care of that one. Now, in general, how do you know whether there's going to be 0, 1, or 2 solutions? Well, here's some rules for you. Given that you've got a side-side angle, if the side opposite the given angle is greater than the other side, there's only going to be one solution. If the side opposite the given angle is less than the other given side, there's either going to be 0 or 2 solutions. Not 1, but 0 or 2. So in this last problem we had, let's take a peek. We were given a side, and an angle, and the side opposite the given angle was less than the other side given, because 2 is less than 10. And we had 0 solutions. So that fits this last premise right here. The side opposite the given angle is less than the other given side. There's either 0 or 2 solutions. So let's go through these other situations. So in this case, we're looking to solve this triangle where A is 126, B is 12, and C is 2. So here again is a side, and an angle. And the side opposite the given angle is actually greater than the other side. So by our rules, side opposite the given angle is greater than the other side. There's only going to be one solution. So I know I'm only going to have one triangle in this case. So let's start using law of sines. We can find angle C first. So the sine of C over 7 is equal to the sine of 126 over 12. Sine C equals 7 sine 126 over 12. And I end up with the sine of C equaling 0.472. So C is equal to the inverse sine 0.472. Again, we'd leave that in our calculator without rounding. So our value then will be C is equal to 28.16 degrees. So let's just write in 28.16. Now I know I can use a subtraction from 180 to get angle A. A equals 180 minus 126 minus 28.16, and I get 25.84. And then finally I need to find the side A, so I take A over the sine of 25.84 is equal to, I'm going to use the given information, 12 over the sine of 126. Therefore A is equal to 12 sine of 25.84 over the sine of 126, and A will be equivalent to 7.09. And we've solved the triangle. So again, we've dealt with the following two situations: side opposite, given angle greater than the other side, where we had one solution; side opposite, given angle less than the other side, 0 solutions. So now we're going to deal with the two solution case. So let's go through and do that. So in this case, I have angle B is 35, side B is 50, side A is 65. Two sides and an angle given. Side opposite the given angle is less than the other side. And we're going to state that there's two possible solutions. Well, let's find the first one. We'd have to use a law of sines to calculate A. So I know that sine of A over 65 is equal to the sine of 35 over 50. So A, just like in our previous problems, is equal to the inverse sine of whatever is 65 sine 35 over 50 equal 48.21 degrees. I subtract from 180 to get C, so C equals 180 minus 35 minus 48.21, which ends up being 96.79 degrees. And then I could find side C by doing another law of sines. So C over the sine of 96.79 equals 50 over the sine of 35. C equals 50 sine 96.79 over the sine of 35, or 86.56. So let's go ahead and write some of these in. I know in this case that I have this side A, or angle A, of 48.21, and this is 96.79 rough. So now, but this is a situation where we said that we're going to have 0 or 2 solutions. Well, I've already found one solution, so how do we find the other solution? Well, the situation is this: no matter what happens, I have to keep my initial conditions. I have to keep that basically I have a side of 65, a side of 50 next to each other, and this angle connected to the 65 of 35 degrees. Well, if that's the case, then I can use now this compass to find my other side. Now, you don't need a compass, but what you do need to know is that a compass draws circles, and on a circle, any line that I draw from the center point is equally distant from that point, because that's the definition of a circle. So I take and I bring this point up here and say, hey, right now the distance from C to A is 50. Now if I swing this at all, what happens is I create an arc, and on that arc I am equidistant from that point C. So let's go ahead and actually draw this now. Here's that arc, and notice that arc comes back and hits the triangle again. So given that, what I know is that I can draw a line from that point to that new intersection and create another triangle such that I have a side of 65, a side of 50, because this dotted line is still 50 away because that's on the same arc of the circle, and an angle of 35. My new triangle looks like this green guy right here, which certainly looks nothing like the initial black triangle. But I still have the same initial conditions. Now the key is, well, how do I know which side I move? Well, there's a way to do that as well. Basically, what you want to do is you want to use the angle between the given sides is your pivot. So that's the point, or that angle is the vertex of the angle that you swing. Then you want to swing opposite side. So here's the opposite side into the given angle. So here's that opposite side, and we swung it into the given angle, and you'll create this new triangle. Now in this new triangle, here's something we know. Again, here's my new triangle to the left, but in the triangle to the right, this triangle is an isosceles triangle because I have two sides of 50. We know from geometry that base angles are equal in an isosceles triangle, so this angle over here is also 48.21. I know that this is a straight line, so 180 minus 48.21 is going to give us that supplementary angle, which means that this guy right here is 131.79. And if I know that's 131.79, I now know this angle up here because I just have to subtract from 180, which gives me this angle C being 13.21. Finally, I can find my missing side C by using a law of sines and just say the sine, or C over the sine of 13.21 is equal to 50 over the sine of 35. And we end up with C equaling 19.92. So we have one solution of the triangle in black here, the other solution in the green and red down here, and those are our two triangles. Again, follow this rule. Take the angle between the two given sides as your pivot, swing the side into the given angle, thus creating an isosceles triangle, and then you can get all the pieces of this little triangle. Let's do it again just for practice so you can see it. We take and find C. So what I'm going to do is I'm going to create my triangle. I got a 65-degree angle for A. 15 is the side opposite. Call B, I guess right here, C up here, and side B is 16, so I have the side opposite the given angle is less than the other side. There should be two solutions. All I'm really concerned about is finding angle C. So I'll go ahead and find angle B first, since that's the only thing I can find. We'll take the sine of B over 16 is equal to the sine of 65 over 15. B, once again, is equal to the inverse sine of 16 sine 65 over 15, which is 75.17. Subtract that from 180 to get C. C equals 180 minus 65 minus 75.17. We have a C value of 39.83. So that's one possible situation. And we knew B was 75.17. So now I'm going to take the angle between the two given sides, use that as my pivot, and swing the side opposite into the given angle. Something like this. Doesn't have to be totally accurate, but I'm going to create a new triangle. And in that new triangle, this dotted line is also 15, so that base angle is equally 75.17. Therefore, I have a new triangle, like so, where I have 65, 15, 16, and this right here is 75.17. So now if I subtract from 180, I end up with 104.83 as this angle down here. This is my new B, if you will. And then I can find my new C by subtracting from 180 again. And I get a C value of 10.17. So here's one value of C, here's the other value of C, and there's a couple examples of how to swing that. Again, side angle is the theme of the day, and you've got to pay attention to how many solutions you're going to have as a result. Fill out your lesson summary, do your Connect Ed, and we'll get back to you tomorrow.